Direct 3D 7.0 introduced support for hardware-accelerated transform and lighting, T&L, for Direct 3D, while OpenGL had this capability already exposed from its inception. 3D accelerator cards moved beyond being just simple rasterizers to add another significant hardware stage to the 3D rendering pipeline. The NVIDIA GeForce 256, also known as NV10, was the first consumer-level card released on the market with hardware-accelerated T&L, while professional 3D cards already had this capability. Hardware transform and lighting, both already existing features of OpenGL, came to consumer-level hardware in the 90s and set the precedent for later Pixel shader and Vertex shader units, which were far more flexible and programmable. 2000 to 2010. NVIDIA was first to produce a chip capable of programmable shading, the GeForce 3, codenamed NV20. Each pixel could now be processed by a short program that could include additional image textures as inputs, and each geometric vertex could likewise be processed by a short program before it was projected onto the screen. Used in the Xbox console, it competed with the PlayStation 2, which used a custom vector unit for hardware-accelerated vertex processing, commonly referred to as VU0/VU1. The earliest incarnations of shader execution engines used in Xbox were not general purpose and could not execute arbitrary pixel code. Vertices and pixels were processed by different units which had their own resources, with pixel shaders having much tighter constraints, being as they are executed at much higher frequencies than with vertices. Pixel shading engines were actually more akin to a highly customizable function block and did not really run a program. Many of these disparities between vertex and pixel shading were not addressed until much later with the unified shader model. By October 2002, with the introduction of the ATI Radeon 9700, also known as R300, the world's first Direct 3D 9.0 accelerator, pixel and vertex shaders could implement looping and lengthy floating point math, and were quickly becoming as flexible as CPUs, yet orders of magnitude faster for image array operations. Pixel shading is often used for bump mapping, which adds texture to make an object look shiny, dull, rough, or even round or extruded. 44, with the introduction of the NVIDIA GeForce 8 series, and then new generic stream processing units, GPUs became a more generalized computing devices. Today, parallel GPUs have begun making computational inroads against the CPU, and a subfield of research, dubbed GPU computing or GPU for general purpose computing on GPU, has found its way into fields as diverse as machine learning, 45, oil exploration, scientific image processing, linear algebra, 46, statistics, 47, 3D reconstruction, and even stock options pricing determination. GPU at the time was the precursor to what is now called a computer shader, for example CUDA, OpenCL, Direct Compute, and actually abused the hardware to a degree by treating the data passed to algorithms as texture maps and executing algorithms by drawing a triangle or quad with an appropriate pixel shader. This obviously entails some overhead, since units like the scan converter are involved where they are not needed, nor are triangle manipulations even a concern except to invoke the pixel shader. NVIDIA's CUDA platform, first introduced in 2007, 48, was the earliest widely adopted programming model for GPU computing. More recently, OpenCL has become broadly supported. OpenCL is an open standard defined by the Khronos Group, which allows for the development of code for both GPUs and CPUs with an emphasis on portability. 49. OpenCL solutions are supported by Intel, AMD, NVIDIA, and ARM, And according to a recent report by Evans Data, OpenCL is the GPU development platform most widely used by developers in both the US and Asia Pacific. 2010 to present. In 2010, NVIDIA began a partnership with Audi to power their cars' dashboards, using the Tegra GPU to provide increased functionality to cars' navigation and entertainment systems. 50. Advances in GPU technology in cars has helped push self-driving technology. 51. AMD's Radeon HD 6000 series cards were released in 2010 and in 2011. AMD released their 6000M series discrete GPUs to be used in mobile devices. 52. The Kepler line of graphics cards by NVIDIA came out in 2012 and were used in the NVIDIA S600 and 700 series cards. A feature in this new GPU microarchitecture included GPU Boost, a technology that adjusts the clock speed of a video card to increase or decrease it according to its power draw. 53. The Kepler microarchitecture was manufactured on the 28nm process. The PS4 and Xbox One were released in 2013. They both use GPUs based on AMD's Radeon HD 7850 and 7790. 54. NVIDIA's Kepler line of GPUs was followed by the Maxwell line, manufactured on the same process. NVIDIA's 28nm chips were manufactured by TSMC in Taiwan, using the 28nm process at the time. Compared to the 40nm technology from the past, this new manufacturing process allowed a 20% boost in performance while drawing less power. 55. 56. Virtual reality headsets have very high system requirements. VR headset manufacturers recommended the GTX 970 and the R9 290X or better at the time of their release. 57. 58. Cards based on the Pascal microarchitecture were released in 2016. The GeForce 10 series of cards are under this generation of graphics cards. They are made using the 16 manufacturing process, which improves upon previous microarchitectures. 59. NVIDIA has released one non-consumer card under the new Volta architecture. The Titan V changes from the Titan XP. Pascal's high-end card include an increase in the number of CUDA cores, the addition of tensor cores, and HBM2. Tensor cores are cores specially designed for deep learning, while high-bandwidth memory is on die, stacked lower-clocked memory that offers an extremely wide memory bus that is useful for the Titan V's intended purpose. To emphasize that the Titan V is not a gaming card, NVIDIA removed the GeForce GTX suffix it adds to consumer gaming cards. On the 20th of August, 2018, NVIDIA launched the RTX 20 series GPUs that add ray tracing cores to GPUs, improving their performance on lighting effects. 60. Polaris 11 and Polaris 10 GPUs from AMD are fabricated by a 14nm process. Their release results in a substantial increase in the performance per watt of AMD video cards. 61. AMD also released the Vega GPU series for the high-end market as a competitor to NVIDIA's high-end Pascal cards, also featuring HBM2 like the Titan V. In 2019, AMD released the successor to their graphics core Next, GCN, microarchitecture /instruction set. Dubbed as RDNA. The first product lineup featuring the first generation of RDNA was the Radeon RX 5000 series of video cards, which later launched on July 7, 2019. 62. Later, the company announced that the successor to the RDNA microarchitecture would be a refresh, dubbed as RDNA 2. The new microarchitecture was scheduled for release in Q4 2020. 63. AMD unveiled the Radeon RX 6000 series, Its next-gen RDNA 2 graphics cards with support for hardware-accelerated ray tracing, at an online event on the 28th of October, 2020. 6465. The lineup initially consisted of the RX 6800, RX 6800 XT and RX 6900 XT. 66, 67. The RX 6800 and 6800 XT launched on November 18, 2020, with the RX 6900 XT being released on December 8, 2020. 68. The RX 6700 XT, which is based on Navi 22, was launched on the 18th of March, 2021. 69, 70, 71. The PlayStation 5 and Xbox Series X and Series S were released in 2020. They both use GPUs based on RDNA2 microarchitecture with proprietary tweaks and different GPU configurations in each system's implementation. 72, 73, 74. Intel first entered the GPU market in the late 1990s, but produced lackluster 3D accelerators compared to competition at the time. Rather than attempt to compete with the high-end manufacturers Nvidia and ATI/AMD, they began integrating Intel graphics technology GPUs into motherboard chipsets, beginning with the Intel 810 for the Pentium 3, and later into their CPUs, beginning with the Intel Atom Pineview laptop processor in 2009 and moving into desktop processors beginning with the first generation of the Intel Core line, and contemporary Pentiums and Celerons, in 2010. This resulted in a large nominal market share as the majority of computers with an Intel CPU featured this embedded graphics processor. These generally lagged behind discrete processors in performance. They re-entered the discrete GPU market on March 30, 2022, with their Arc series competing with then current GeForce 30 series and Radeon 6000 series cards at competitive prices. GPU companies. Many companies have produced GPUs under a number of brand names. In 2009, Intel, Nvidia and AMD/ATI were the market share leaders, with 49.4%, 27.8% and 20.6% market share respectively. However, those numbers include Intel's integrated graphics solutions as GPUs. Not counting those, Nvidia and AMD control nearly 100% of the market as of 2018. Their respective market shares are 66% and 33%. 75. In addition, Matrox, 76, produces GPUs. Modern smartphones also use mostly Adreno GPUs from Qualcomm, PowerVR GPUs from Imagination Technologies and Mali GPUs from ARM. Computational functions. Modern GPUs use most of their transistors to do calculations related to 3D computer graphics. In addition to the 3D hardware, today's GPUs include basic 2D acceleration and frame buffer capabilities, usually with a VGA compatibility mode. Newer cards such as AMD/ATI HD 5000, HD 7000 even lack dedicated 2D acceleration. It has to be emulated by 3D hardware. GPUs were initially used to accelerate the memory-intensive work of texture mapping and rendering polygons, later adding units to accelerate geometric calculations such as the rotation and translation of vertices into different coordinate systems. Recent developments in GPUs include support for programmable shaders which can manipulate vertices and textures with many of the same operations supported by CPUs. oversampling and interpolation technique. Questo reduce aliasing, and very high precision color spaces. Several factors of the GPU's construction enter into the performance of the card for real-time rendering. Common factors can include the size of the connector pathways in the semiconductor device fabrication, the clock signal frequency, and the number and size of various on-chip memory caches. Additionally, the number of streaming multiprocessors, SM, for NVIDIA GPUs, or compute units, CU, for AMD GPUs, which describe the number of core on-silicon processor units within the GPU chip that perform the core calculations, typically working in parallel with other SM/cores on the GPU. Performance of GPUs are typically measured in floating point operations per second or flops, with GPUs in the 2010s and 2020s typically delivering performance measured in teraflops, TFLOPS. This is an estimated performance measure, as other factors can impact the actual display rate. 77. GPU accelerated video decoding and encoding. The ATI HD 5470 GPU, above, features UVD 2.1, which enables it to decode AVC and VC1 video formats. Most GPUs made since 1995 support the YUV color space and hardware overlays, important for digital video playback, and many GPUs made since 2000 also support MPEG primitives such as motion compensation and IDCT. This process of hardware-accelerated video decoding, where portions of the video decoding process and video post-processing are offloaded to the GPU hardware, is commonly referred to as GPU accelerated video decoding, GPU assisted video decoding, GPU hardware-accelerated video decoding, or GPU hardware-assisted video decoding. More recent graphics cards even decode high-definition video on the card, offloading the central processing unit. The most common APIs for GPU accelerated video decoding are DXVA for Microsoft Windows operating system and VDPAU, VARPI, 15MC, and 15BA for Linux-based and Unix-like operating systems. All except XFAMC are capable of decoding videos encoded with MPEG-1, MPEG-2, MPEG-4 ASP, MPEG-4 Part 2, MPEG-4 AVC, H.264/DivX6, VC1, WMV3/WMV9, XVID/OpenDivX, DivX4, and DivX5 codecs, while 15MC is only capable of decoding MPEG-1 and MPEG-2. There are several dedicated hardware video decoding and encoding solutions. Video decoding processes that can be accelerated. The video decoding processes that can be accelerated by today's modern GPU hardware are motion compensation, MoComp, inverse discrete cosine transform, IDCT, inverse telesign 3:2 and 2:2 pull-down correction, inverse modified discrete cosine transform, IMDCT, in-loop deblocking filter, intraframe prediction, inverse quantization, IQ, variable length decoding, VLD, more commonly known as slice-level acceleration, spatial temporal deinterlacing and automatic interlace /progressive source detection, bitstream processing, context adaptive variable length coding /context adaptive binary arithmetic coding, and perfect pixel positioning. The above operations also have applications in video editing, encoding and transcoding. Neural network training. Given that most of these computations involve matrix and vector operations, engineers and scientists have increasingly studied the use of GPUs for non-graphical calculations. They are especially suited to other embarrassingly parallel problems. One notable use of GPU is in neural networks training. In research done by Indigo, it was found that while training deep learning neural networks, GPUs can be 250 times faster than CPUs. GPU forms. Terminology. In personal computers, there are two main forms of GPUs. Each has many synonyms. Smiley 78. Dedicated graphics card, also called discrete. Integrated graphics, also called shared graphics solutions, integrated graphics processors, IGP, or unified memory architecture.